So let's take a look at our last suggested problem here. I actually haven't made the video for question 14 yet, but I'll make that one later in the week. So let's take a look again at 5-27. So two plants in a cross were each heterozygous for two gene pairs. Big A, little b over little a, big B. So let's see. So A and B over little a and big B. Two parents, so parent 1 here looks like this. Parent 2 is identical, males and females, and we're not talking about Drosophila here, because the question tells us that crossing over occurs during the formation of both male and female gametes. Okay, and we know crossing over doesn't happen in males in Drosophila, so we're not talking about Drosophila. Also for this question, big A and big B are dominant to little a and little b. And so what we need to do is determine the phenotypic ratio of the offspring from these crosses. And A and B are 25 centimorgans apart. Okay, so let's just take a look at this. This should be, I think it's going to be easy. Let's see. So each plant, I'm assuming it's a plant, but let's see. Each individual here can make 4 types of gametes. Again, so big A, little b, little a, big B. And these are the non-crossover gametes. And little a, big B. Nope. Little a, little b, that's a crossover gamete, right? So crossover happens. Combine little a with big B. And big A with big B. Okay, and these are the crossover gametes. And we've already been told that these are 25 centimorgans apart. So out of let's say out of 100 gametes, 25% of them should be recombinant. So 25% of 100 is 25. 25 of them should be crossover gametes. And let's go over here for these guys. 75 would be non-crossover gametes. And so it's easier to work with even numbers. So let's go with, instead of 100, let's go with out of 200 gametes. So out of 200 gametes, 25% of them are going to be crossover gametes. So 25% of 200 is 50. And the rest, 75% of 200 is 150. Okay, so in all of the gametes from individual 1 here, 150 are going to be non-crossover. Half of those 150 are going to be big A, little b, and half are going to be little a, big B. Okay, of these, 25 are going to be little a, little b, and 25 are going to be big A and big B. Okay, so if we just randomly took 200 gametes from this individual and genotype them, figure out the genotype of them, 75 should be this, 75 this, 25 this, and 25 this. So the same thing should happen with this one over here, right? Because it's the same genotype, same arrangement of alleles. So to figure out the phenotypic ratio, what we need to do is assume that these gametes right here are going to be randomly combined with the same ratio of gametes over here. Okay, that seems kind of complicated, doesn't it? How are we going to do that? Okay, I think I have an idea. I'm gonna map this out a little bit before I try and do it, before I try and record it. Okay, hold on 1 second, please. Okay, so I think I figured it out, and I haven't actually gone through the problem all the way yet, but let's do it together here. So essentially, I think what we're looking at is a giant forked line method problem here. So for example, I'm going to take these guys right here. Let's take these. I've tried to change my pen color. Okay. So we know of all the gametes from each individual, 75 are going to be this one, 75 this one, 25 this one, 25 this one. So I want to copy this, and then I want to paste it down here, and I want to shrink it. Okay. And I want to switch back to my yellow pencil here. And so we have 200 possible gametes here. 75 out of 200, you can do the math if you want to check, but that's 3/8. So 3/8 are going to be big A, little b. 3/8 are going to be little a, big B. 1/8, 25 out of 200 are going to be little a, little b, and 1/8 are going to be, oh, I forgot what it was, big A, big B. Okay, so 1/8 of the gametes are going to be big A, big B, 1/8 little a, little b, 3/8 little a, big B, 3/8 big A, big B. And these are going to be fertilized by gametes from the other parent, which are found in the same ratio. Right? I can go back up here and show you that. So the genotypes were exactly the same here. And so the gamete ratios are going to be exactly the same. And remember, we got those ratios because the genes are linked and they're 25 centimorgans apart. So let's take a look. How would we combine these using the forked line method? We are just going to do this. So 3/8, 3/8, 3/8 big A, little b, 3/8 little a, big B, 1/8 little a, little b, and 1/8 big A, big B. So these ratios right here are just the same as the ratios on the left here, right? So when we multiply these across, let's start doing this. 9 over 64, 2 big A's, 2 little b's. And then we have 9 over 64, big A, little a, big B, little b. 3 over 64, big A, little b, little b, and 3 over 64, big A, big B, little b. Okay, I hope I didn't make a mistake there. If I did, you probably caught it. So keep that mistake in mind as I go through and try to solve the others here. So for this one, I just got to do the same thing. 3/8 big A, little b, times 3/8 little a, little b. Now 1/8 little a, little b, and 1/8 big A, big B. Okay, multiply those across. 9 out of 64, little a, big B, little b. 9 out of 64, little a, big B. 3 out of 64, little a, big B, little b. And 3 out of 64, big A, little a, big B, big B. Oh, okay, I ran out of space. I'm gonna have to. Okay, I'm gonna put another big B right here. Okay. So this is fun. I think it's fun. I hope you think it's fun. I could do this all day. Well, this is Saturday, and I've been recording these videos for about 5 hours now. So I hope some of you find them useful. So okay, so let's repeat this. 3/8. Okay. So, okay, I messed up somewhere right here. So again, I'm just copying this down here, and this is just a giant forked line method problem. 3 out of 64 are going to be big A, little b, little b. 3 out of 64, little a, big B, little b. I'm starting to realize why this was problem number 27. It is a long problem. Not a spicy problem though. I haven't assigned any spicy problems yet. But okay, so this is 1 out of 64, little a, little b, little b. 1 out of 64, big A, big B, little b. And my hand is getting tired. Okay. I don't think I've had a cramp in my hand since multiplication tables in elementary school. At least I remember 8 times 8 is 64 because of that. So, okay, let's multiply this. Okay, I'm just repeating everything. And this better give us the right answer here, because this is taking a long time. So 3 over 64, big A, big B, little b. 3 over 64, big A, big B. 1 over 64, big A, big B, little b. 1 over 64, big A, big B, big B. Now I wonder if we have to combine some of these. Okay, I'm going to do some copying and pasting and get these all down at the same level so we can compare them more easily. Okay, first one here, select and copy and paste. I'm going to shrink it just a little bit. Oh, I'm going to try to shrink it. Come on, baby, shrink. Okay, there we go. Okay, let's get the next group. Copy and paste and drag and shrink. You little son of a... Okay, here we go. Okay, there's the other 4. I'm going to use my mouse here. Copy and paste and drag and shrink. Okay, let's see if I can squeeze one more in here. The last one. Copy and paste and move. Oh, I'm going to really have to shrink this one. Shrink. Okay. So the question, these are all the genotypes we got from our giant forked line approach to this problem. And the question is asking us for the phenotypic ratio of the offspring of crossing. And let me just, why not? Why don't I... Big problem here. I mean, this is a big problem. I don't think we have a big problem yet. I think this is just a long problem. So, okay, we crossed A, B, A, B, right? A, B, Yes. Okay, we cross these two. Genes are 25 centimorgans apart. And when we do that, well, we get these genotypes and these ratios. And are they all unique? Let us see if that is the case. I'm going to pause this for 1 second. So I think the easiest thing for us to do might be to scroll down a little bit and now just focus on the phenotypes, because the question just wants the phenotypes. Okay, so let's see here. So what I'm going to do is I'm just going to rewrite all of these with just the phenotypic information. So I'm just going to either write a big A for the big A phenotype, and a big B for the big B phenotype, a little a for the little a phenotype, little b for the little b phenotype. So 9 out of 64 are going to be big A, little b for the phenotype. And so what I did, I just took this 9 out of 64 here and put that here. So 9 out of 64, these guys right here, are going to be big A, big B. 3 out of 64 are going to be big A, little b. 3 out of 64 are going to be big A, big B. Again, so I just transferred these numbers, these genotypes down here, and I only listed the corresponding phenotype for each. So, and you can see that's kind of useful, right? Because right away we can see that this 9 out of 64 right here goes with this 3 out of 64 right here. So we can simplify the amount of information in this answer. And we'll do that in a moment. So I'm going to change the color because I think it's kind of fun to change the colors. So I'm just focusing on this group over here. So 9 out of 64 are big A, big B. 9 out of 64 are little a, big B. 3 out of 64 are little a, big B. And 3 out of 64 are big A, big B. Okay, changing the color again. And I better write small because I'm running out of space. So 3 out of 64, big A, little b. 3 out of 64, little a, big B. 1 out of 64, little a, little b. 1 out of 64, big A, big B. And the last one, 3 out of 64, big A, big B. 3 out of 64, big A, big B. 1 out of 64, big A, big B. 1 out of 64, big A, big B. And I should probably point out that there's probably a shorter way to do this, but this works too. Okay, so now we just need to combine these numbers. So I want to find, what do I want to find first? So I want to find all of the offspring that have the big A and the big B phenotype. So 9 out of 64 here. So 9 plus 9 out of 64. 3 here. 9 here. Plus 3 here. Plus 1 here. Plus 3 here. Plus 3 here. Oh, okay, these are all big A, big B. Okay, plus 2 here, these guys. Okay, so now I want to find the little a's and the little b's. So let us see. Little a and little b. 1 here. And is that it? Okay, so far that's it. Okay, big A and little b. Let's find those. 9 here, 3 here, okay, 3 here, and okay, so let's find now let's find the last one, little a and big B. Okay, little a and big B. We have a 9 here, and 3 here, and 3 here. So 9 plus 3 plus 3. Okay, so we have all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different genotypes here. Well, 16 different genotypes leading to just the phenotype information, 16 different bits of phenotype information, and we simplify down here. Let's add these up. So I'm gonna 2 plus 3 is 5, 8, 9, 12, 21, 24, and I hope that's 33. So 33 out of 64 are going to be the big AB phenotype. Only one, poor little only little one out of 64 is little a, little b. Poor little guy or girl. 12, 15 out of 64 is going to be big A, little b, and 15 out of 64 is going to be little a, big B. And if we did everything right, this should add up to 64 out of 64. 33 plus 1 is 34, plus 15 is 39, 49, plus 15 is 54, 64. Okay, so I think that is the answer. I don't have my solutions manual with me. Let me see if I can look that up real quick. Let me see if I got logged out. Should just take a second. I haven't looked up the answers to the other questions I have done, so you're going to have to let me know if I made a mistake somewhere. I believe all those answers are accurate, though. And those would be in the other videos. I plan on uploading these to YouTube or Reginet or something like that, so you guys can have access to them. So let me see the solutions manual. I'm going to be excited if this is right, because that took a while. And okay, my Adobe Flash isn't working. Oh, here, okay, here it goes. Here it goes. We're looking at Chapter 5, Problem 27. Let's see, what's the answer? Did we get it right? And we did. Let me see. 15, 15, 1. Yep. Okay, we got it. Excellent. Okay. So again, if you have some questions, come see me during office hours, or just email me to make an appointment outside of office hours. Or again, you can ask me in class, and there's usually always 15 or 20 minutes after class before the next class comes in, and you can ask me questions then. Okay, so I hope you like this video, and I'll try and make these throughout the semester, because I know not all of you can come to office hours or have extra time to come see me. So, see you in class.